In the brutal game of evolutionary survival, there is one rule that every single animal knows by heart: if it smells like a killer, run. For a mouse, the sharp, pungent scent of cat urine is the ultimate biological alarm bell. It is a chemical warning sign encoded deep within their DNA that says, if you stay here, you will die. Under normal circumstances, a mouse exposed to this smell will experience an immediate spike in stress hormones and bolt in the opposite direction. But sometimes, a glitch occurs in the system. Sometimes, a rodent doesn't run. Instead, it stops. It sniffs the air. And then, it does something that defies every rule of survival: it follows the scent. It walks directly toward the smell of its number one predator, seemingly entranced, completely erasing its survival instincts. Biologists call this bizarre phenomenon feline fatal attraction. It is a literal, evolutionary death wish. And the rodent isn't doing this because it's brave, or stupid, or tired of living. It's doing it because its brain has been completely hijacked by a microscopic puppet master. Today, we are peeling back the layers on one of the most chilling, mind-bending biological tricks in the natural world: how a single-celled parasite can rewrite the neural code of a mammal, turn its fear into love, and force it to walk straight into a predator's mouth. Welcome to Nerdy Nonsense. Let's get weird. To understand why this glitch exists, we have to meet the mastermind behind it, a tiny, single-celled protozoan parasite named Toxoplasma gondii. Toxoplasma is an equal opportunity infector. It can invade virtually any warm-blooded animal on Earth, from birds and sheep to chimpanzees and humans. But there is a massive evolutionary catch: the parasite can only reproduce sexually inside one specific place, the digestive tract of felines. Cats are its definitive hosts. Every other animal on Earth is just a temporary stepping stone. This creates a massive logistical nightmare. If Toxoplasma is trapped inside a mouse, how does it get back into a cat to complete its life cycle? It can't walk. It can't fly. It has to wait for the mouse to be eaten. But wild mice are incredibly good at not being eaten. They have spent millions of years perfecting the art of predator avoidance. If Toxoplasma just sits around playing the passive waiting game, it might never reproduce. So, it stops waiting. It takes active control. Once ingested by a rodent, Toxoplasma transforms into rapidly multiplying forms called tachyzates, hitching a ride through the bloodstream directly to the brain. There, they settle down and form dormant, lifelong structures called bradyzoid cysts. From this cozy, neural headquarters, the parasite begins to systematically dismantle the mouse's hardwired survival instincts. It doesn't just make the mouse clumsy or slow. It specifically, and targetedly, erases its innate, genetic fear of cat odor. For the parasite, this is a masterpiece of natural engineering. By turning the mouse's fear of cats into an eerie attraction, it practically guarantees that its host will end up as dinner, delivering the parasite right back to the feline gut, where it can finally find a mate. If you think this kind of mind control is unique to mice, think again. The natural world is absolutely crawling with real-life zombie puppet masters. In the African savanna, hyena cubs infected with Toxoplasma show a bizarre, confident lack of fear. They will wander significantly closer to lions than their uninfected peers. A high-risk behavior that regularly gets them killed, passing the parasite along. In Yellowstone National Park, gray wolves harboring the parasite are dramatically more likely to make high-stakes, high-risk decisions. They are over 11 times more likely to leave their pack to start a new one, and a staggering 46 times more likely to become a pack leader. Even our closest living relatives aren't immune. Infected chimpanzees completely lose their innate, deeply ingrained aversion to the scent of leopard urine. And Toxoplasma is just one member of a terrifying club. Hairworms chemically brainwash crickets, forcing them to jump into water and drown themselves, so the adult worm can swim free. Ophiocordyceps, the infamous zombie ant fungus, hijacks an ant's muscles, forcing it to climb high up a plant, clamp its jaws onto a leaf, and die in the perfect humid zone, for the fungus to grow a spore-launching stalk out of its head. and the Euhaplorchis fluke takes over the brains of killifish, forcing them to dance and shimmy at the surface of the water, practically waving a neon sign to catch the attention of predatory birds. Across the entire animal kingdom, parasites are rewriting host behavior to serve their own reproductive agendas. But how? What is the actual, physical machinery behind this mind control? So how does Toxoplasma know it has successfully made it into a cat, and not some dead-end host, like a mouse, a wolf, or a human? It all comes down to a highly specific, quirky detail of feline metabolism. Cats are strict carnivores. Because of this specialized diet, they never evolved the gut enzyme needed to metabolize a specific fatty acid, called linoleic acid. While every other mammal on Earth breaks this acid down immediately, felines leave their digestive tracts flooded with it. To the parasite, linoleic acid is a massive, molecular neon sign. The moment it detects this fatty acid in its environment, it essentially goes, "Aha! We are in a cat." Initiates sexual reproduction. But how does it manipulate its intermediate hosts to get there? Scientists have spent decades trying to crack this biological black box, and they have uncovered a fascinating, multi-layered chemical toolkit. One of the most powerful tools is dopamine, the neurotransmitter of reward, motivation, and risk-taking. In a shocking discovery, geneticists found that Toxoplasma gondii actually carries its very own functional copy of the gene for tyrosine hydroxylase. This is the critical, rate-limiting enzyme that mammals use to build dopamine from scratch. The parasite isn't just tricking the host's brain into releasing dopamine. It is actively brewing and secreting its own supply of brain chemicals. To prove this, a landmark scientific study, led by Dr. Joanne Webster at the Royal Veterinary College, engineered mutant strains of Toxoplasma to overproduce this tyrosine hydroxylase enzyme at medium and high levels. They placed rats infected with these different strains into a classic fatal attraction assay, a testing arena where one corner was scented with cat urine, while the other corners contained control odors, like rabbit urine, water, or the rat's own scent. This made sure they were measuring a response to a predator, not just curiosity about random smells. The results were stunning. There was a direct, dose-dependent curve. The more dopamine-producing enzymes the parasite expressed, the more time the rat spent lingering in the cat zone. The chemical mimicry of the parasite was directly driving the animal's self-destructive behavior. This brings us to the ultimate, million-dollar question that has captured the internet's imagination. If this parasite can rewrite a rodent's brain, what is it doing to the 2 billion humans currently harboring it? Sensationalized headlines love to scream that your domestic cat is secretly driving you insane, making you reckless, or causing major psychiatric disorders. And to be fair, there are some highly intriguing, associative studies out there. Active Toxoplasma infections have been linked to slower human reaction times, a higher risk of motor vehicle accidents, increased impulsivity, and even traits like entrepreneurship. Which, let's be honest, is a massive financial risk. But as scientists, we have to ask a crucial question. Does the parasite cause risk-taking, or are naturally risky people, the kind who eat undercooked meat, garden without gloves, or drink unfiltered water, just more likely to catch the parasite in the first place? To settle this, researchers turned to the gold standard of human data, the Gondii longitudinal study, in New Zealand. This study tracked a representative birth cohort of same-aged individuals, from childhood all the way to age 38. Because everyone was the exact same age, it eliminated cumulative age-related exposure biases. Out of 837 individuals tested, 28.2% were positive for Toxoplasma antibodies. Researchers ran these participants through a grueling battery of clinical psychiatric interviews, standardized memory tests, and official administrative record searches. And their conclusion? On the whole, there was little to no evidence that latent Toxoplasma infection was related to increased risk of psychiatric disorders, poor impulse control, personality aberrations, or cognitive decline in healthy human adults. While the biological mind control of Toxoplasma in wild rodents is an undeniable, horrifying scientific reality, our human brains seem to be far more resilient. Your cat might be demanding, and they might wake you up at 3 a.m. for food, but they aren't using microscopic parasites to turn you into a zombie. Ultimately, the wonky, terrifying world of host-parasite interactions is a reminder of just how wonderfully complex and strange our biosphere really is. The fact that a microscopic, single-celled organism can evolve a precise chemical key to unlock and manipulate the brain chemistry of an animal millions of times its size is an absolute marvel of evolutionary biology. It shows us that science isn't just about reading textbooks or memorizing formulas. It is a living, breathing detective story where some of the biggest plots are being written by the smallest creatures. So, what do you think is the most mind-blowing parasite trick we talked about today? Let us know in the comments below. And if your brain's grumpy librarian hasn't pruned the memory of this video yet, give your synapses a high-reward dopamine hit, smash that like button, hit subscribe to Nerdy Nonsense, and ring that notification bell so you never miss a weekly dose of science. Until next time, keep your curiosity alive, stay skeptical, and keep your distance from cat pee. CYA